Welcome to tonight's installment of Mr. Rainier Helps Us with Our Homework. This is installment 9 in this video series of How Do I Do My Homework? So hopefully this one helps. Today in class we talked about continuity and differentiability. The big idea that we came to at the close of today's lecture was that a function, if it's differentiable, it is continuous at that point. So everywhere a function has a derivative, a function is continuous. We also made mention of the fact that if a function is not continuous at a point, then that function cannot be differentiable at that point. So in tonight's homework, there are several questions where they ask us to identify, based on a graph, where the function is differentiable. So if you take a look at your book, grab your book, open it up to problems 32, 33, 34, 35, 36. Actually, I guess it starts with 33. Those questions specifically address whether or not a function is differentiable based on our reading of a graph. If you look at problem 33 has two places where we would tend to think we have to focus our attention. One is the point that's in the second quadrant, the point of the graph, not a point x, y, but the graph reaches a point or a corner or a cusp. And then the graph has a jump at 0. The instructions simply say, identify where the function is not differentiable. Well, again, in class today, we concluded that if a function is not continuous, it's not differentiable. So at x equals 0, that function has a jump. Therefore, it's not continuous. So the function not being continuous at 0 means it's not differentiable at 0. Off to the left in the second quadrant at x equals -4, there's a cusp or a corner or a point or a kink, whatever you want to call it. The graph has an instantaneous change in the slope of the tangent line at x equals -4. That, we said today on the board, is another example of someplace where the derivative doesn't exist because of that instantaneous change in the slope of the tangent line, the derivative being a limit. That limit from the left won't agree with the limit from the right, therefore a lack of differentiability. So in number 32, or 33, I keep wanting to make that 32, in number 33, it's not differentiable at x equals -4 because of the cusp or the corner, and it's not differentiable at 0 because of the discontinuity. If we look at 33, at 33 we have an opportunity to again have a point or a cusp at x equals +3, so we're not going to be differentiable there because of the instantaneous change in the slope of the tangent line at that point. And at x equals 0, we have a discontinuity. While the function is defined at 0, there's a vertical asymptote there, so the function is not continuous at 0. Again, because it's not continuous, it's not differentiable. If you go to 34, 34 has, again, like the previous two problems, oh, I'm sorry, it's 35. I am not going to get these numbers right once today. In problem 35, there's a hole at x equals 4. Well, that hole is a type of discontinuity, so the function is not differentiable at x equals 4. Also, on problem 35, there's a new type of problem with a derivative. If you look at x equals -1, that function, the tangent lines there, end up being vertical. Now, we didn't talk about this in class. I left it till the homework tonight, and I left it till the video tonight to reward those of you that are watching the video. So we have another item to add to our notes on the list of when is a function not differentiable. We already have corners and cusps and jumps and holes and vertical asymptotes, which those last three tie into continuity. But now we have a sixth item for our list, if you want to count them, and it's where a function has a vertical tangent line. Because the tangent line being vertical, that means the slope fails to exist. And if the slope fails to exist, the slope is the derivative. So if the slope fails to exist, the derivative fails to exist. Therefore, the function is not differentiable. So at x equals -1 on problem 35, our function is not differentiable. And to finish up these 4 problems that I'm helping you with tonight, if we look at problem 36 has a jump at x equals -1. That's a type of discontinuity, so the function is not differentiable there. And it has a corner or a cusp at x equals 2. Well, at x equals 2, because it has a corner or cusp, that's an instantaneous change in the slope of the function there. Sorry, an instantaneous change in the slope of the tangent line there. Therefore, that function is not differentiable at x equals 2. I hope this helps. Have a good evening. I'll see you tomorrow in class.